In this video, we're going to talk about how to factor polynomials by grouping. So one thing we're going to talk about is factoring by GCF. So remember, to determine the GCF, you're going to look for the largest number that will evenly divide the coefficients and the highest power of the variable that can be factored out of every single term. The GCF of an expression can be a constant or some other monomial. So if we look at 2x squared plus 10x minus 8, notice that we can evenly divide every single term by 2. So what we're going to do is factor out a 2, so that means we're going to pull the 2 out in front, and then we're going to divide each of these terms by 2 and then simplify. So that gives us the factored form, which is 2 times x squared plus 5x minus 4. If we're going to factor 6x cubed plus 12x squared minus 18x, notice that each of these terms is divisible by 6, so we have a GCF of 6, and also notice that the highest power of x we can pull out of every term is x. So we're just going to go ahead and write our GCF as this monomial, which is 6x, because every term in this polynomial is evenly divisible by 6x. So we're going to write the 6x in front, and then we're going to do 6x cubed over 6x, 12x squared over 6x, minus 18x over 6x, and then we're going to simplify. So that gives us 6x times x squared plus 2x minus 3. In this case, we can actually factor further, because x squared plus 2x minus 3 can be factored as x plus 3 times x minus 1. So that's an extra step to keep in mind whenever you're working with these factoring problems. You want to factor completely. So if you ever get to the last step and you see something that can be factored a little bit further, go ahead and do that. So let's try this example now. Let's factor 12x cubed plus 20x squared minus 4x. So always I'm going to start off by looking for a GCF. Well, notice that here, the GCF, I can divide everything by 4. And also I can factor an x out of every term. So I'm going to go ahead and write my GCF as 4x. And so that means I'm going to put the 4x in front, and then I'm going to divide every single term in this polynomial by 4x. And then I'm going to go ahead and simplify. So I have my 4x in front, and then 12x cubed over 4x is going to give me 3x squared. And then plus 20x squared over 4x is going to give me 5x. And then minus 4x over 4x, that's just going to be minus 1. So now I have 4x times 3x squared plus 5x minus 1. And that's the factored form of this expression. So now you can go ahead and pause the video and try doing this example on your own. So here, notice that there is a GCF. You can actually divide every single term in this expression by 7. 7 is the only thing we can factor out because every single term doesn't have a variable, because we have this 21, which is our constant term. So our GCF is just going to be 7. So I put the 7 in front, and then I divide every single term in this expression by 7. So that gives me 7 times 4x cubed plus 2x squared plus x plus 3. So another type of factoring we can do is when we see something called common binomial factors. So in this case, our GCF is actually going to be a binomial. And it's going to look a little bit different because if you see here, it doesn't jump out at you as a GCF. But what happens here is we have 5x times x plus 3 minus 16 times x plus 3. What I want you to notice here is that this x plus 3 is actually common to both of my terms. So that entire binomial, I can just make that kind of like my GCF, and I can factor that out. So what I'm doing here really, and this is looking way more complicated than you would actually write out, but I'm just writing it so you can see where this is coming from. So I take that x plus 3 and put it in front, and then what I'm actually doing is dividing an x plus 3 out of each of these terms. So you can see here when I do that, these x plus 3's will cancel, and then I'm just left with x plus 3 times 5x minus 16. So this is one way to think about it, but usually when we're doing these problems, we'll just say, okay, you write the common binomial, okay, that x plus 3, and then you just kind of look at those terms that are remaining on the outside, so this 5x and minus 16, and then you write that as another binomial. Okay, so that's kind of like the way we remember it. So now let's go ahead and try this example. Let's factor 4x times x minus 1 plus 9 times x minus 1. So notice here my x minus 1 is my common binomial, so I'm just going to write this as x minus 1, and then I'm going to write what I have left on the outside. Okay, so notice that that's 4x plus 9, and so that's how you would go about factoring this expression. So now you can go ahead and pause the video and try doing this example on your own. So notice here I have my common binomial, which is x plus 2. So I just write my x plus 2, and then the terms I have left on the outside are x minus 5. So this just becomes x plus 2 times x minus 5. So now let's get to the main point of this lesson, which is factoring by grouping. So factoring by grouping is one way to factor a polynomial that has 4 terms in it. Okay, so what we're going to do is we're going to start off always by looking for a GCF, right? This is how factoring problems always start. So we want to factor out a GCF if there is one. So if I'm working through this example, x cubed plus 2x squared minus 25x minus 50, I don't have a GCF, so I'm going to go ahead and go to step 2. In step 2, what I'm going to do is I'm going to take these terms, so I have 4, and I'm going to put those 4 terms into 2 groups. Okay, so that means there's going to be 2 terms in each group. So put the first 2 terms together, x cubed plus 2x squared, and then the second 2 terms together, minus 25x minus 50. Now I'm going to look at each of these groups separately and factor out the GCF. Okay, so if I look at x cubed plus 2x squared, those terms have a GCF of x squared that I can factor out. If I look at minus 25x minus 50, I'm going to factor out a negative 25. Okay, the GCF of both of these terms is 25, but why did I factor out the negative? That's just something we do anytime the first term in this pair is negative. We just go ahead and factor the negative out along with it. So now we're just going to go ahead and simplify everything. So when I simplify this first set, I get x squared times x plus 2. When I simplify the second set, I get minus 25 times x plus 2. So notice now I have my common binomial, right? I have x plus 2 in both of these terms, so I'm going to go ahead and factor that out. So I have x plus 2 times x squared minus 25. Okay, so normally I'd be done, but remember we're factoring completely. Okay, so if something jumps out at you that can be factored further, you want to go ahead and do so. Hopefully now you'll recognize that this x squared minus 25 is the difference of squares. So we're going to go ahead and rewrite that as x minus 5 times x plus 5. So now this is the fully factored form of this expression. I have x minus 5 times x plus 5 times x plus 2. So now let's go ahead and try this example. So I'm going to always start off by looking for a GCF. Okay, so I notice here that every single term is divisible by 2, and I do have a variable in every term, so I'm going to factor out as many x's as possible. So it looks like the highest number of x common to each term is going to be just 1. So I'm going to go ahead and factor a 2x out of every single term in this expression. So I'm going to go ahead and write that out now. And so that's going to give me 2x times, this first term is going to simplify to x to the 4th. 4x to the 4th over 2x is going to become 2x cubed. Minus 16x squared over 2x is going to become minus 8x. Minus 32x over 2x is going to become minus 16. So now I need to work on factoring these 4 terms I have on the inside. Okay, so I'm going to leave my 2x in front, and then I'm going to work with that polynomial on the inside. So I'm going to do the same steps I did before. So I'm going to put the terms into 2 groups. So I have x to the 4th plus 2x cubed, and then plus I'm going to do negative 8x minus 16. Now I'm going to factor the GCF out of each group. So from this first group, I can factor out an x cubed. So I have x to the 4th over x cubed plus 2x cubed over x cubed. And I'm just going to go ahead and simplify that before I get to my next step. So x to the 4th over x cubed is just going to be x, plus 2x cubed over x cubed is just going to be 2. Now let's go to the second group. So here I'm going to factor out an 8, but I'm going to go ahead and factor that negative along with it. So that's going to be negative 8, and then I'm just going to divide both of these terms by negative 8. So when I do that, that's going to give me minus 8 times negative 8x over negative 8 is just going to be x. Minus 16 over negative 8 is going to be plus 2. Okay, so now I'm going to factor out that common binomial that you see, that x plus 2. So let's go ahead and do that. So we have 2x times x plus 2 times x cubed minus 8. Okay, where did I get that x cubed minus 8? I actually got that from these terms that are remaining on the outside. So this problem gets even more interesting here because notice that this x cubed minus 8 is actually the difference of 2 cubes, right? So remember we have that factoring pattern, that a cubed minus b cubed, and that equals a minus b times a squared plus ab plus b squared, okay? So in this case, since a cubed is equal to x cubed, that means that a is going to equal x. Since b cubed is equal to 8, that means b is going to equal 2. So I'm going to go ahead and write this now as x minus 2 times x squared plus x times 2 plus 2 squared. So that's going to become x minus 2 times x squared plus 2x plus 4. And all of that is the factored form of this expression here. So when I write this in fully factored form, I'm going to have 2x times x plus 2 times x minus 2 times x squared plus 2x plus 4. Okay, so there was a lot of extra steps in that one, but now this is the fully factored form. So now you can go ahead and pause the video and try doing this example on your own. So in this one, notice we do have a GCF. We can factor a 2 out of every term, and we can also factor out an x. So we get 2x times 2x to the 4th over 2x minus 2x cubed over 2x plus 4x squared over 2x minus 4x over 2x. When we simplify this, we get 2x times x cubed minus x squared plus 2x minus 2. We put the terms in two groups. We can factor an x squared out of the first group, and we can factor a 2 out of the second group. So that's going to give us 2x times x squared times x minus 1 plus 2 times x minus 1. Notice our common binomial is x minus 1, so we're just going to write an x minus 1 here. And then the terms that we have remaining on the outside are x squared plus 2. So the fully factored form of this expression is 2x times x minus 1 times x squared plus 2. So remember, when factoring polynomials with 4 terms or more, you can use factoring by grouping. You're going to group the terms into pairs that have a common factor and then factor out the GCF of each group. Then you can factor out the common binomial factor of each group.